this is sort of what we're going to be doing in lab tomorrow. And it's all about figuring out what is going to limit your reaction. And I know that's pretty obvious by the words limiting reactant, but look at this problem. This is the actual problem here, this one line, 8.51 moles of H2 and 9.25 moles of oxygen. And then there's this reaction here, all right? So notice they're telling you how much of both of the reactants you actually have, all right? Now, we're gonna make water, and the real question with this is how much water can you make, all right? But also, which of these is gonna run out? And then whichever one has extra, the one that doesn't run out, how much is left over, all right? So with these problems, you're gonna have to figure out all of that stuff, all right? This is the flow for it. It's convert both of the reactants into the product you're looking for, all right? So we're gonna convert this and this into water. So it's two separate problems. Once we have it as water, whichever one is the smaller number, that's how much we can actually make, all right? Now, why would it be the smaller one? Because the smaller one signifies, well, it's gonna run out. So we can't make any more if that's a smaller one, all right? And that's gonna be the limiting reactant, which we'll abbreviate LR. It's the smaller products reactant. Then we use this limiting reactant because that's gonna be the smaller part. We're gonna convert the limiting reactant into the other one, because that'll tell us how much of the other one we're actually going to use. And then we can do a subtraction. How much of the excess was given minus the excess used, that's how much of it would be left over, all right? And the basic idea, again, is just trying to figure out what's the limiting reactant, how much water can be produced or how much product can be produced, and then how much of the other reactants left over, all right? So let's do this. Okay, what's gonna go on the bottom? Moles of hydrogen, good. What's gonna go on the top? Yeah, moles of H2O. And in this problem, because they're giving us moles, they didn't kind of tell us to find grams or anything. We're just gonna keep it in moles. We're gonna keep this problem pretty simple. We're gonna just stop it right here. All right? But if they start you with grams, then you would find grams of what you're looking for. Okay, what are the numbers gonna be? H2O is gonna be a what?
2.
And then the H2 is gonna be? 2, all right, they're gonna cancel out, right? H2 is gonna cancel out, the 2's are gonna cancel out, so it's gonna give us 8.51 moles H2O. All right, great. Now we do the exact same thing, but with the other reactant. 9.25 moles of O2. All right. On the bottom, now we're gonna have moles of O2. And on the top, we're still gonna have moles of water, because that's what we're looking for, right? All right, and then we look at the numbers. Oxygen is a 1, water is a 2. All right, so now we have this. The moles cancel out. 9.25 times 2 is gonna give us what, 18.5?
Yeah.
All right, so now we have these two numbers. Well, which one is how much water we can make? Yeah, the smaller one. This is how much we can actually make, because if you use up all, now this is the concept here, if you use up all of the hydrogen, you can only make this much water, right? If you use up all of the oxygen, you can make 18.5 moles of water. Well, which are you gonna use up first? You're obviously gonna use up this one first because it's a smaller number, all right? So that's what we're looking for, and this is how much water is produced. So we would, maybe circle it or label it. In these kind of problems, they actually ask you to just fill in these little lines and whatnot. So we'll just do that. 8.51 moles of water, that's how much water would be produced. What's the limiting reactant?
H2.
Yeah, the H2, because it's related to the smaller number. Okay, so that's going to be our LR. All right, for limiting reactant. All right, what does this number mean, 18.5? Exactly, by your silence, you're telling me what it means. It means nothing. Because we can't make it, right? We can't make it because we don't have enough hydrogen to make it there. So cross it out. Just give it a line. Now, why do you want to cross it out? I'm glad you asked. You want to cross it out because of step 3. Use the limiting reactant to convert to the excess. So you don't want to use this one to do the next step. You want to use this one. You want to use 8.51 because we're going to figure out how much of the excess we're going to use. All right? What is the excess? We didn't identify that yet.
The oxygen?
Yeah, the oxygen. Good. So we can put a little XS there. You get the joke? Excess, instead of spelling it out, it's X in it. Yeah? It's funny, right? No?
Yes, I like it.
Thank you. All right. If you like it, like the video. All right.
I subscribe.
Okay, so yeah, subscribe. All right, so what are we going to convert this into? H2 into what? What'd you say? Yeah, moles of H2 are going to go on the bottom. What's going to go on the top? What's that? We're trying to convert it into the excess reactant, so we're going to convert it into oxygen. Okay, so if we go back to our problem, oxygen would be 1, H2 would be 2, and this is going to tell us how much oxygen is used. So 8.51 divided by 2 is about 4.26 when you round because of sig figs, right? 8.26 moles of O2. Now, this is, oh, I'm sorry, thank you. Don't take away that like. All right, 4.26 moles of O2 used. Okay, so this is moles of O2 used. All right, which you didn't ask for, but that's okay. It's still information we're getting from the problem. What did it ask for? How much is left over, right? So we have the excess given minus the excess used. The excess given is 9.25 moles of O2 minus what was used, 4.26 moles of O2. And that's going to give us the excess left over, which is what? 4.99?
Yeah.
Okay, so we figured out the limiting reactant from the smaller of the two here. We then figured, because we knew the limiting reactant, we could figure out how much oxygen is used, the 4.26, and then because we know how much oxygen was given, we can subtract and figure out how much oxygen is left over, all right, how much excess is left over. Any questions with any of that? No? The conversions aren't bad, it's just remembering what everything means. That's the tricky part with this.